Okay, here we have the Unit 1 retest review. So if you didn't do well on the Unit 1 test, go ahead. I'm going to kind of walk you through some problems on this retest review. So the first problem here is talking about a profit. So you're given the equation. It's a parabolic equation here, so you know this is a parabola opening downwards. It has a y-intercept there of 48. And then it asks you a variety of questions here. So the first question says, for what number of products does the company have zero profit? What you need to know here is that zero profit means that they're asking you to find the roots. So the roots are when the y value or the p value, the profit is 0. So you plug that in a 0 for p. I factored out a -2. So negative 2x squared divided by negative 2 is x squared. Positive 4 divided by a negative 2 is negative 2. And then a positive divided by a negative is a negative 24 there. Once you get to there, you factor this trinomial, so you need to multiply to a negative 24 and add to a negative 2. So you know it's going to be a positive and a negative, and the difference needs to be 2. So I went ahead and chose 6 and 4. So you're going to have a negative 6 times positive 4 is negative 24. Negative 6 plus 4 gives you that negative 2. So these are your factors, which means that the roots are positive 6, negative 4. Since here we're talking about the number of products that a company is producing, I reject this negative 4 because it doesn't make sense. I can't produce negative 4 products. And I kept the 6 as my answer. And here it said it was in thousands, so it would be 6,000 products would produce zero profit. Okay? In part B here, how many products does a company have to sell to achieve a maximum profit? So this is really asking you to find the axis of symmetry, the x value. So remember that's negative b over 2a. So negative 4 divided by 2 times a is negative 2. So that gives you 1, and that's in thousands. So 1,000 products would need to be sold to maximize the profit. And then the next question is asking, well, what is that maximum profit? So what you need to do is you need to plug in this 1 into this profit equation. So profit at 1. If you plug in a 1 wherever you see an x, 1 squared is 1, times negative 2 is negative 2. 4 times 1 is 4, plus 48. So I think when you add that up, that gives you 50. And again, we're talking about profit in thousands, so I said $50,000. So that's how you tackle that first one. The next question is asking about the domain. So what I'd like to remind you is that your denominator is not allowed to be 0. So basically what we're going to do here is we're going to find out what numbers are not allowed to be in the domain, and then we're going to exclude them from the set of real numbers, so from negative infinity to infinity. So in this case, the denominator, I say that that denominator is not allowed to be 0. Add 64 to both sides, and then you take the square root. Remember, the square root of 64 is 8, but when you take the square root of something that's plus or minus, so that means that positive 8 and negative 8 are excluded from the domain. So that means my domain goes from negative infinity until negative 8, union negative 8 to 8, union 8 to infinity. This middle piece is the one that a lot of people missed on the test, okay? And don't forget, when you're taking the square root, don't forget the plus and the minus. The next domain question is a square root question. So just a reminder, you can't take the square root of a negative number. So you have to take the argument, the part underneath the radical, and you have to say that has to be greater than or equal to 0. So subtract 19, divide by 3, and you get that x has to be greater than or equal to negative 19 thirds. So greater than that means it can be that, so negative 19 thirds all the way to infinity is your domain there. Okay? So we'll kind of move on to the next page. Okay, the next two questions have to do with even and odd. So remember, our goal with even and odd is you're plugging in negative x, and if you get back the original, that tells you the equation is even. If when you plug in negative x, you get back the complete opposite, that tells you that it's odd. And if neither of those things happen, then it's not even or odd. So in the first example, when I plug in negative x, wherever I see an x, I pop in a negative x. Then, when I simplify this, well, the absolute value, that means that it's going to be positive. So here, because this is f of x, that's the original. So kind of think of yourself as working down vertically, okay? I get back the original thing. So when I plugged in a negative, I got back the original, so that one's even. Over here, when I plug in a negative, wherever you see an x, in parentheses, okay? So be careful. When you cube a negative, it's still negative. So a negative x cubed times a negative 2, because that 2 is negative, gives me a positive 2x cubed. Over here you have a negative squared as a positive, but then it's negated here, so you have negative x squared, and a plus 2 is a plus 2. Now this one's interesting because when you plugged in negative f of x, it's not the same, right? It's definitely not the same because this sign changed. So this is not the same, so it's not even, but it's not the complete opposite. Notice that the sign here changed, the sign there is the same, and then the sign there is the same. So this is not even or odd, okay? So you have a negative. All right, so here you would say this does not equal f of x, and it does not equal negative f of x. So therefore, neither. This did not equal the complete opposite or give you back the original. So this one is neither. Okay, on the next one here, we're saying plug g of x into f of x. Now notice here, this doesn't have any restrictions. You could actually factor out a 5 there to simplify it for yourself. So, but there's no restrictions there. But I'm just going to take this g, plug it into f. So we're going to say that f of g of x is 8, and then you drop this in where the x is, 5x plus 10 divided by 5, and then a minus 3. Go ahead and you can kind of clean that up. So if you distributed the 8, you would get 40x plus 80 divided by 5 minus 3. Okay? Then, if you wanted to go a little further, again, you could have kind of taken out that 5 right away. Now you can pull out more than a 5, but we'll just say you take out a 5 from that numerator, so you get 8x plus, okay, and then if you divide this by 5, right, you get 16 over 5 minus 3. Those 5's cancel. So then you can say 8x plus 16 minus 3, and then your final answer could be something like 8x plus 13. Might have been a little easier if you would have canceled that out from the beginning and then gone from there. Here you could even talk about the domain, but there was no restrictions on the domain here, since this didn't have any restrictions on the domain and this didn't have any restrictions. Remember, your final answer, you might have to pay attention to the domain of that, okay? All right, on the next one, it says, consider the graph below, determine the intervals in which the function increasing, decreasing, constant. So remember, you're increasing and decreasing and constant. Your answer for here, these are x values, okay? And your local mins, these are y values, okay? So increasing over what x values is the function increasing? Well, from here to here, it's falling. So this graph looks a little bit hard to read, but it looks like each graph is just one. So that's 1, 2, 3, 4, 5, 6, 7. So this is -7 there, okay? So it's decreasing from -7 all the way until -6, -5, until -4, okay? And then it's increasing, constant, and then it's decreasing again from 0 to 1. So from 0 to 1, union, and then it's decreasing again. There's 1, 2, 3, 4, 5, 6, 7, 8. So decreasing there over that interval. And we see that then it's increasing, right, from -4 to -3. So -4 to -3, union, and then it's increasing again from 1 until 5. And then it's increasing again from 1, 2, 3, 4, 5, 6, 7, 8 until 9, 10, 11, 12. Okay? And then it was just constant from -3 to 0. So -3 to 0. So we have those as our intervals of increasing, decreasing, and constant. The domain on here, that's the x value, so this goes from -7 to 12, it looks like. Okay, if there were arrows, then we could say it was going, on, but I only see the domain here from -7 is included and 12 is also included. And then the range, the lowest value I see is a -3. So the range is -3. The highest value is 1, 2, 3, 4, 5, 6, 7. So we'll say the 7, and we got that. Your local minimum, so a minimum, remember, that's going to be, here's a minimum, there's a minimum, and there's a minimum. Anytime the graph goes from decreasing to increasing, so we've got those 3 minimums there. So you could say that there's a minimum that was y equals -3. So you could say y equals -3, y equals -1, and y equals -2. If you wanted to write them as coordinates, you could, but just know that the minimum itself is the y value. Okay? So then go ahead and switch pages. Okay, so on this inverse question, you were given f of x and asked to find the inverse, g of x. So remember, when finding the inverse, the first thing you want to do, you change f of x to y. Then you're going to switch wherever you see an x, you put a y. Wherever you see a y, you put an x. And then our goal here is to solve for this y. So with this y, there's a square root, a 3, and this 1 that we need to get rid of. The first thing you're going to do is subtract 1 from both sides. So if you subtract 1 from either side, right, then you can kind of go over here. You end up with x minus 1 as the square root of y plus 3. Now you're going to undo the square root by squaring both sides. And then to get this y by itself, the last thing you're going to do is subtract 3. Now notice that that minus 3 is going to be attached to the squared on the outside. So that's what we get, and we're calling this the inverse, so we kind of rewrite it saying that the inverse, sometimes it's used that f -1 of x notation, that inverse notation, but here it says to call it g of x. So we went ahead and called it g of x, that's the inverse, okay? And hopefully from algebra 2, you remember that square roots and quadratics there are related, they are inverses, so it makes sense that we get a quadratic there. Next, it says graph them on the same set of axes. So I kind of tried to color code it. I took the original f of x. Hopefully you know this is a square root curve shifted to the left by 3 and up 1. So you could have taken your original square root curve that had a point at 0, 0 and shifted it to the left 3, up 1, and sketched from there. The other way you could have done it is to create a table. So a smart choice here to plug in would be a -3. So when you plug in a -3, you get 1. Plug in a -2, you get 2. And if you plug in a positive 1, you get square root of 4 is 2. 2 plus 1 is 3. Okay, so I made some smart choices here. I would recommend that you actually use your transformations to kind of graph that, and that will give you an idea of what you want to plug in. Then, to get the inverse, that g of x, you could say, well, this is a parabola that shifted to the right by 1 and down 3. So think of that parabola, shifted to the right by 1 and down 3. We're only going to see that right-hand side because this original came with a restricted domain, so that's why that happens. Or you could have just taken these points and flipped the x and the y, and then replotted them. When you graph it, it is going to be the reflection over the line y equals x. So you can kind of see that going on here. My graphs aren't perfect, but you kind of see if you kind of folded that over, it should kind of land on, the blue one would kind of land right onto that pink one. So that's how you find the inverse. Next, you have to prove that it's the inverse by first taking g of x and plugging it into f of x. So here's the g of x. If you take this and you plug it in for x right there, so you're taking this expression and we're plugging it in for the x value right there. And then we're simplifying. So once you kind of have that, those 3's cancel, squares and square roots cancel, the 1 and the positive 1 cancel, you get to x. Then you need to do it the reverse way. Now you need to take this f of x and plug this in for x right here. So you're taking this big square root thing and plugging it in right there. So it becomes that minus 1 squared minus 3. Well, this plus 1 and minus 1 cancel. The square and the square root cancel. And then finally the 3 and the negative 3 cancel. Since they both reduce to x, they are inverses. So you could say, you know, since f of g of x equals g of f of x, they are inverses. Therefore, inverses. Okay? So that's how you find the inverses on that one. Alright, in the next one we are just doing a transformation. So it's going to have the squared shifted 3 units to the right. Remember, that's going to occur inside. So it's going to be y equals, leave yourself some space there. So it's going to have the same shape is a squared, but it's going to the right. So remember, that's going to be x minus 3. That would shift it to the right. Shifted 2 units up. A vertical displacement occurs outside of the parentheses. Reflected across the x-axis, that means there's going to be a negative on the outside. Then give the domain and range of the function. Well, the domain for every single parabola is going to be all real numbers. So domain is going to be all real numbers. And the range, remember, this parabola is already opening downwards. So even if you just did a super quick sketch, right, if you went to the right 3, up 2, but you're opening downwards, you're looking something like this. So that means that your range is going to be negative infinity until this point here. Well, remember, we shifted to the right and up 2, so that's going to be a positive 2 right there. Okay, the next one is just asking if you know what the parent function is. I'm realizing you kind of can't see that very well. It is an absolute value function, so I don't know if you can see it. Hopefully you've got the paper. So it is just this V shape. That's the shape of your absolute value graph. Okay. Normally it has a point at 0, 0, but this one has been shifted. Okay. And it appears, I know it's hard to see, but this is 2 and this is 4. So it appears to have been shifted to the right by 3. Okay. And then also down by 4. Okay. So this is the point here. I'm saying that this point is going to be 4, comma, negative 4, that vertex there. So based on that, it says, what's the graph of the parent? Well, the parent was just the absolute value curve, so the absolute value of x, and the equation of this, so it's going to be y equals, remember, a horizontal shift is the opposite of what you think, and it occurs within the absolute value bars, so shifting it to the right is actually going to be a minus 4. And down 4 is also going to be shifting it 4 that way. Oh, actually I lied. This is going to be a 3. So we'll change that to a 3. Sorry, it was hard to see. So I'm saying that this here is the point 3, negative 4. And so that would be a 3 there. Sorry about that. Okay. And then you can go ahead to the next page. Okay, for this next one, we are asked to graph the piecewise. So when I first start graphing, I'm going to graph this first. I always kind of try to, in my head, say what I think it's going to be. So this is a parabola. It's opening downwards, but it's shifted up 2. So you can kind of envision what a parabola shifted up 2, but opening downwards would look like, okay? But this constraint is saying, I don't want the whole parabola. I only want the part where the x's are less than 0. So you can graph it that way, or you can do a table, okay? So when I did a table, you always start by plugging in this number. So you plug in 0. 0 squared is 0, negated still 0, plus 2 gives me 2. I make myself a note there that that is going to be an open circle because that 0 is not included in the domain. Then you plug in x less than 0. So plug in a couple more numbers that are less than 0. I chose negative 1 and negative 2, and you plot those points. When you just plot those points, it can be confusing if you just have those points. That's why I made a note here that I reminded myself it was a quadratic reflected, so it kind of helps you get a little bit more of that shape to it. This should not look like a line. It's a quadratic. Next, I graphed the pink one. So on the pink one, I made myself a note in the beginning that this is a line. It has a positive slope and a y-intercept of -1. If you're not sure, you could just graph the part of the line where x is greater than or equal to 0, so you could just graph it. But you could also do a table. You always start by plugging in the number it gave you. Here you plug in x equals 0, so 0 minus 1 gave me -1. It's a closed circle because that inequality has that bar underneath. So it was a closed here, and you could just graph the rest of it saying, slope is +2, right 1, +2, right 1, or you can, plug in more values for the table. I chose to do 0, 1, and 2 because 0 is here, and it's at x greater than 1, so I had to do, 1, 2, 3, etc. Once you have the graph, it then just asks you a couple questions. What is the value of f of -2? So you could either go -2 here and see what your output is, or you could just take that -2 and say, well, -2 is less than 0, so I have to plug that -2 into this equation here. Be careful when you're plugging in a -2, it's -2 squared, which is 4, but then it's negated. So you have a -4 plus 2, which is -2. The domain, this is opening to the left forever. This is headed to the right forever, so your domain is all real numbers. This piece is headed down forever. This piece is headed up forever with no gaps in the range, so that's also all real numbers. Whenever you have a jump in y values like that, that is called a jump discontinuity. So we've got that one graphed. All right, number 10, we're getting towards the end here. So in number 10, you're given a piecewise, and this is really all about knowing which part of the piecewise to plug into. So these constraints are telling you what values you're allowed to plug in to which piece. So here, the x value is 4. Since 4 is greater than 3, you plug it into this piece. So you say 4 minus 3 is 1. The absolute value of 1 is still 1. Minus 2 is negative 1 for my answer there. Next, you're plugging in a negative 3. Well, negative 3 is less than 0, so you have to plug it into this top piece of the piecewise function. When I plug in a negative 3 squared is 9, plus 2 times negative 3 is a negative 6, so 9 minus 6 gives me 3. For part C, it's asking you to plug in 2. 2 falls in this part of the domain, that middle piece, so 2 minus 5 gives you negative 3. All right, now this one is a little harder. It's a composition. So first you need to plug 1 into F, so 1 falls in this middle piece. So if I was just doing f of 1, okay, it would be 1 minus 5, and that gives me negative 4. But now I need to plug in negative 4 again. So it's really, this is saying f of negative 4 now. So now negative 4 has to go into a different piece. So a negative 4 goes into there, so negative 4 squared is 16, right? But then it's minus 2, it's plus 2 times that negative 4, which is a negative 8. So 16 minus 8 gives me 8 as a final answer there. Okay. Number 11 is a decomposition of functions. It's saying that h of x is a composition, and it's asking you to figure out, well, what were the two things that you put together to make that h of x? So here, h of x is the absolute value of that stuff in the middle. So what did you plug in to what in order to get this? Well, since here g is being plugged into f, g is going to be the stuff inside the absolute value bar. So I kind of actually start here. So g is the stuff inside. So notice that this is inside. And also, which part of this is inside? Well, it's that part. So it's the x squared minus 4. And what did you plug that into? Well, you plugged it into these absolute value bars. So f of x must have been absolute value of x. If I take this g, plug it in to that for x, it would give me this. That means it was a composition. Number 12, describe the sequence of transformations to get, oh, that's a typo. This should be a 3. Okay. To go from x cubed to this. Okay. Well, here you need to be really careful. This was the most missed question on the entire test, and it was because people forgot to factor this out, and we had one like it on your pocketbook, so if you need another example, be sure to go back to the pocketbook to revisit. So this is the equivalent. I'm just going to kind of rewrite it over here. It's going to be the same thing as negative. If I factor out a negative 1 there, it's going to switch the sign of that 7. Okay? Now you can more clearly see that this is a shift to the right. This is moving you to the right 7. This is a reflection over the y-axis, and this is moving you down 2. Okay? So we have a reflection over the y, You also have to the right by 7. That was the part that people messed up. They all said to the left because they didn't factor it out. And then we're also going down 2. So then also down by 2 units. Okay. All right, the last one here. The graph of y equals ln of x has a vertical asymptote and a point. Okay, so remember, our ln curve, there's a lot of people that kind of confuse the ln with the square root curve. Guys, your ln curve is like this. Okay? Remember, it has a vertical asymptote at x equals 0. So there's a vertical asymptote here at x equals 0. And it has this key point at 1, 0. So if you were shifting this, okay, you can shift it horizontally by kind of changing what's going on with this x in parentheses, or you could take that point and shift it up and down if you just had, a plus something or a minus something outside. So I would definitely make sure you go through this retest ticket, go through your test, make sure you do test corrections, and then you will be ready for your retest. Have a great day.